Hello and welcome to section 10.5. So we're going to talk about some properties of logarithms and then how to use those to solve exponentials and logarithmic equations that are a little bit more complex that we saw in the other sections. So let's look at the properties of logs. So can I have these in front of you as you're working through problems? They're going to come in handy. So some basic properties is that a log of 1 is always 0. So it doesn't matter what base you're working on, any base or the natural, the e base, log of 1, it's going to be 0. So this is, if you think of its exponential version, if I change this to an exponential, I get a to the 0 equals 1, right? Anything to the power of 0 is 1. So it's just a restating of that exponential property, but in logarithmic form, right? Next property says that log of a is 1, right? Same ln of e is 1 because it's of base e, right? So if you have the same base of the same number, then you're going to get 1. Again, to make sense, change it to exponential form, get a to the 1 equals a. That makes sense. Anything to the power 1 is just equal to itself. And now these next two are inverse properties. Basically it says the exponential and log cancel each other out. So a, the exponential base a of log base a of x, these cancels out and you just get x. If you have log base a of a to the x, if you have the same base of the exponential, with the log and the exponential, they cancel out and you get x, right? Again, right, if I change this to exponential form, you get a to the x equals a to the x. You can see that they're equal, so they're easy to show that they're equal. All right. Now these next three are probably the ones we're going to use, not the most, but we're going to use in solving equations. So this says that if you take a log of a product, then you can split it up as a sum. So log of m times n equals log of m plus log of n. If you take a log of a quotient, a division, log of n divided by n is log of m minus log of n. And if you take the log of something to a power, then the power comes in front. So that's the p log of a to the m. These come directly from exponential rules, right? If you multiply exponents of the same base, you end up adding the exponents. That's where this is the plus comes from. If you divide things with the same base, then you end up subtracting the exponents. And if you take a number, a base to a base, then you're going to multiply the exponents. So these are direct translations of exponent rules that we've seen before. Okay, so have these in front of you as you're working through things, and then you can use it. All right, so let's look at this example. All right, so let me get rid of this so it's not messy. Solve 2 log base 5 of x equals log base 5 of 81. So we want to get equations like this into this form. Log base of something equals log of the same base of something else. If you have log equals log, then you can cancel this out and make equations out of these. Okay? But you have to have simple 1 log on this side, 1 log on the other, no numbers in front, no numbers added to them or anything like that. Okay? So here we have 2 log base 5 of x equals log base 5 of 81. So this is almost good because you have log base 5 on each side, but this 2 is annoying. It's in the front. So we're going to use this rule right here. If you have a number in front, then it comes up. So this comes up as an exponent. Okay? So we have log base 5 of x to the 2 equals log base 5 of 81. Right? Now these cancel out because we have the same log on both sides. We have x squared equals 81. Take the square root of both sides, so we get x equals plus or minus 9. All right, so we have two solutions. X is positive 9, x equals negative 9. we gotta check. Okay, so we're required to check if you have log equations, because you don't want to take the log of a negative number. Okay, so you have log base 5 of x. If that x is negative, then it's going to give you a domain error if you put in the calculator. So you got to cross this out. Okay, so x is 9 works, but x equals negative 9 does not work.